If you were driving at 70 miles per hour, it would take you about 15 days to drive around the equator, 5 months to drive to the moon, 63 years to drive to Mars at its closest point, and 4,400 years to drive to Neptune. The solar system alone is vast. In 1977, we launched the Voyager 1 probe into space at a speed of 38,000 miles per hour, and it didn't leave the solar system until 2012. Even light, which can go around the Earth 7 times in 1 second, is relatively slow compared to the size of the solar system. We're zooming out at about 500 times faster than the speed of light. Usually it would take 8 hours for light from the sun to reach this distance, but we did it in about 1 minute. The solar system is massive, but it is much smaller than the Milky Way galaxy. The Milky Way has approximately 300 billion stars, many of which have their own planets. Our closest neighboring star system, Alpha Centauri, is 4.3 light-years away. To give you an idea of the vastness, if our solar system were shrunk down to the size of a US quarter, Alpha Centauri would be 300 feet away. It would take 4,400 years to drive to Neptune, so you can imagine how much longer it would take to reach the next star. Even something traveling at the speed of Voyager, 38,000 miles per hour, would take 77,000 years to get there. The next star system is incredibly distant. Approximately 1 light-year from the Sun, it's 1 or 2,000 times larger than the orbit of Neptune. And for those of you wondering this is how far Voyager has made it, let's continue our journey. That's Betelgeuse, a star that's 640 light-years away and 1,000 times bigger than our Sun. We'll come back to Betelgeuse in a moment. As we keep zooming out, you will see the radiosphere. This is how far our earliest radio transmissions have traveled over the last 100 years or so. Our radio transmissions, although highly degraded by now, have reached about 15000 star systems, just 120 millionth of the stars in the Milky Way. And there is Betelgeuse again. If you look at Betelgeuse in the night sky tonight, the light that you'd be seeing left its surface about 100 years before Columbus sailed for the New World. It's been traveling that long at the speed of light, and is just now reaching our planet. What's even more astounding is, in universal terms, Betelgeuse is fairly local, and to blow your mind even more, our radiosphere is just a tiny blip in the Milky Way. Let's take that quarter analogy from earlier to the next level. If our solar system was again shrunk down to the size of a US quarter, the entire Milky Way galaxy would be about the size of North America, and there would be another 300 billion quarters, which represent other star systems and their planets. Imagine that for a moment, quarters spread out all over North America, approximately every 300 feet in all directions. We are just one of these 300 billion quarters floating around in this massive sea of stars and planets beyond our galaxy. There are at least 1 trillion more galaxies. A trillion, that's a massive number. That's 1 million times. Let's simplify that. Let's say you have a group of 1,000 cats, and there are 1,000 of these groups, so 1,000 groups of cats, each with 1,000 cats in them. That's 1 million cats now for 1 trillion each and every single cat. Remember, there are 1 million altogether, but each and every single cat would represent another 1 million cats. That's a lot of cat fights. A trillion is 1 million, a million times. It's an insanely huge number. This cat would represent 1 million cats, and this cat would represent another 1 million cats. Every cat here represents 1 million cats. That's how many galaxies are out there, our nearest. The neighboring Andromeda galaxy is currently moving towards us at a high speed, but the vast space between stars makes actual star collisions unlikely. Galactic collisions are more of a gravitational phenomenon. Our local group of galaxies, the Virgo cluster, and the larger Virgo supercluster are just a tiny fraction of the vast universe. There are approximately 100,000 galaxies in the observable universe, with billions more yet to be mapped. Some areas, called voids of obscuration, are blocked from observation by dust and other stars in our Milky Way galaxy. The red points represent galaxies whose light has taken billions of years to reach us, allowing us to see into the past. The cosmic background radiation is the oldest light we can detect, left over from the Big Bang. There are many more galaxies beyond the observable universe, which we cannot see because the light from them has not reached us and may never do so due to the expansion of space. The extent of the universe beyond what we can observe is still unknown. The laws of physics suggest that the universe is much larger than the observable universe, and are arguments for it possibly being infinite. This perspective invites us to consider our place in the universe. Instead of feeling isolated on a tiny planet, we should reimagine ourselves as connected to a vast and potentially teeming universe. The outdated belief that we are separate beings in a dead universe needs to be re-examined. We are not separate but intimately intertwined with the world around us. We are part of the universe, not separate from it, and the force that guides the stars also guides us. Our understanding of the universe can extend beyond cold, hard science, recognizing that we are all made of the same fundamental particles and interconnected through unified fields of energy. You, as an individual, are an expression of the universe perceiving itself. These concepts will be explored further in future videos. Our narrow definition of life needs re-examination, as the line between living and non-living is subjective and constantly evolving. The concept of what is considered alive is debated, with viruses being a prime example. Our understanding of life is incomplete, and we should consider the possibility that life is more inherent and fundamental to the universe than we assume. The universe is not a static machine, but a dynamic and evolving process. It behaves more like an organism than a clock. Could the universe possess a different type of consciousness or intelligence that we cannot comprehend from our limited perspective? This idea ties into the notion that we are not separate from the universe. It is logical to consider that if we are intelligent and alive, then the universe itself may also possess a form of intelligence and life. However, this is a topic that requires further exploration and will be discussed in future videos. It is important to reflect on these ideas and not dismiss them based solely on our existing belief systems. Keeping an open mind and considering new information, even if it challenges our current beliefs, can lead to growth and a more comprehensive understanding of reality. I'm offering a new perspective, not trying to convert anyone. There could be various higher powers guiding us, and the planet itself may possess a different type of intelligence that we struggle to comprehend. Our current understanding is based on oversimplified models, and we overlook the complexity of the planet, stars, and universe. We should remain open to new ideas and update our worldview. One worldview suggests that we are all part of an intelligent living system, where each part has value and purpose. Another worldview sees us as separate beings in a dead universe, fostering fear and a selfish mentality. We are all entitled to our own opinions, and these topics will be explored further in future videos. If you enjoyed this video, please consider liking and subscribing.